The question of what wars will look like in the future weighs heavily on governments and militaries when they're deciding what equipment to buy. The global market in military hardware and software is worth an astounding $1.7 trillion, and Australia wants a cut of it. Defence scientists are working at the cutting edge with a view to selling any advances in local technology overseas. As Greg Hoy reports, some of what they're coming up with is the stuff of science fiction.
Is this the future of the battlefield? Meet the all-terrain Leg Squad Support System, created by DARPA, the US Defence Advanced Research Agency. It's a robotic pack horse programmed to follow US Marines into battle. For greater speed, DARPA has produced the Cheetah, and not far behind in development is an android called the Petman.
The best part about working on this technology is that it gives us a glimpse into the art of the possible.
Much more advanced, however, is the Hulk.
If you want to think about them as wearable robots, that's pretty accurate.
A strap-on robotic exoskeleton.
And we're taking the load off the soldier's back.
Weight-bearing stuff is something that we will look at in time as the Americans go further in that research and development, but it is certainly something that's we're interested in to see where that matures and where it may go.
But the Australian Defence Force is also developing new advanced technology to help take the load off the soldiers' back. At this high-security ballistic and mechanical testing range in Port Melbourne, a revolutionary lightweight ceramic body armour developed by Australian scientists for future frontline troops gets a baptism of fire. The project coordinated by the Defence Materials Technology Corporation.
To our knowledge, there is no better capability anywhere on the planet. Its protective properties are proven, but it's manufactured in such a way with our technology that we can now have much more intricate shapes. You can bring curved shapes into play.
This is an AK-47 bullet before it's been fired at the armour now being tested here for Australian troops and export markets. And this is what it looks like once it's been stopped by the armour. The tragedy is for most of those recently shot and killed on the front line. The bullet has simply missed the armour plate. So the aim now is to manufacture armour with far greater coverage that better hugs the bodies of either male or female soldiers, but while reducing the weight burden of up to 16 kilos of armour that must now be borne by frontline troops.
There's a thing called the Christmas tree effect, where new equipment gets hung off the soldier and they start to look like a Christmas tree.
40 and 50 kilos of weight, it can, together with the climate, make it very hard to function.
Let alone fight. A former regiment commander in Afghanistan, Lieutenant Colonel Mark Jennings, has had to console troops who've lost good mates on the battlefield. Now his unit, Diggerworks, works closely with defence scientists and industry, developing lightweight survivability systems to alleviate the fact that frontline fighting is getting more and more heavily high-tech.
Night vision devices, image intensification via night vision systems, and we also have thermal systems that the soldiers are using. Communication systems, the batteries are probably one of the heaviest components a soldier has to carry.
What we're looking at doing is alleviating that by looking at some alternative ways of power generation, and we're talking about fuel cell technologies, wearable batteries that actually generate power from the motion and the movement of the soldiers themselves.
This science for soldiers has already created lighter, stronger helmets, eyewear and light fabrics that improve protection against improvised explosive devices, the curse for Australian troops in Iraq and Afghanistan. Now scientists are refining the next generation of lighter armoured infantry vehicles for much the same purpose.
We have made so many progresses in the last few years, really in protection systems. Where we're heading for the future is a fantastic direction for a combat soldier.
If that's good news for soldiers on the front line, it's also a great business opportunity for Australian defence industries back home.
There is an enormous market out there, and without doubt we see enormous potential overseas.
At Australian Defence Apparel in the Victorian city of Bendigo, the new ceramic armour has aroused strong buyer interest from foreign law enforcement agencies and militias.
This is something like the third hardest material in the world, called boron carbide. We've learnt to shape it, to produce it in a very thin form. So products like this can be both cost-effectively produced in country.
But even in Australia, where defence science is headed can seem surreal. Australia's Defence Science and Technology Organisation and the US Air Force are backing University of Queensland research to develop a hypersonic scramjet projected to look like this, the Hi-Fire-8, capable ultimately, it's hoped, of flying from here to London in 2 to 3 hours.
We have a pretty good understanding of the aerodynamics and the propulsion of a scramjet and what you need to do to fly efficiently at hypersonic speed. Having the materials that can survive that, work that I've been involved with in the DMTC has really been trying to concentrate on that.
After 10 years at NASA, Professor Michael Smart now heads Queensland University's Centre for Hypersonics, which, under the watchful eye of US Air Force staff, has been conducting experimental launches at Woomera in South Australia and elsewhere.
With good engineering, good science, I really think that a lot of this technology can eventually be taken up by Australian industry and really applied in all sorts of areas.
The same is said of aviation high technology already emerging. Though facing controversial delays, Australia is still considering buying up to 100 US F-35 Joint Strike Fighters. With touchscreen and voice recognition controls, these futuristic stealth fighter bombers are capable not just of short takeoff and landing, but vertical landings on ships like the Navy's new landing helicopter docks already being assembled near Melbourne. The F-35s will come with one important Australian component: advanced titanium tail fins produced by BAE Systems in Adelaide and developed with defence researchers at DMTC.
Investment in defence really is at the high end of performance, and what happens there is this technology then leaches into other areas of manufacturing and other areas of industry. So it's a real incubator, if you like, for technology and development.
The challenge for today's defence scientists, developing commercial opportunities while keeping military forces abreast of rapid changes in the dark arts of war.
There's a nice saying about somebody who said, "I've seen what it's like to have the second best equipment on the battlefield, and it's not pretty."
Would you expect to see robots in the field?
Undoubtedly, we already are. I think it's a long time before we see robots firing weapons at each other, but that day too may come.